let's start with the API now. Okay, so not many people know about this, but there are two ways that you can authenticate or make API request calls. One is what I call the session-based authentication, and that's what the CloudStack UI uses today. The reason why we did that was because if you didn't have this way of authentication, then you would have to put your API secret key every single time you put it, or have some way of storing that within the browser itself. And the second way is how we use the very similar to Amazon EC2, the API key auth. So how do we do a session-based auth? I kind of explained that with how we deal with CRSF attacks. What happens today is you make the specific login API call, and you would pass it user and password and domain, whatever. And typically what you should do is post this command. If you do a git command, then it's obviously it can be read for everybody. But if you do a post, it's a bit more secure. But typically in the login command, you should do post. The CloudStack server accepts both git and post commands. When this happens, when you submit the login API call, you will get a JSON session cookie back, and you will also get a session key token back. And now every request that you send after that, you really have to append the session key to every request, because the browser itself is always going to send the cookie, the JSON cookie back automatically working. And then if you ever want to change the timeout periods for this, you can change this within the Tomcat image structure itself. And then for the API key authentication, this is what I'm going to go through further along in the slides. It's very, very similar to how database API is being generated today. And I'll go step by step on how you can generate the signature. But the drawback of this is it requires a bit more coding to make API calls. And all the API commands itself now requires a signature. Instead of at the top where you take a session key token, there's no code after that. You really only have to append the session key and send it down. Now, people have asked me, well, which version should I use when I'm doing integration? I would say, unless you're doing UI, all other integration on top of CloudStack API, you should use the API keys. The reason for that is it's very hard. I mean, the way that user and password is sent down, it's customizable within CloudStack. So, for example, today we have a default MD5 hash, which is not very secure. But someone else may want to change it to SHA-256. Someone may say, I want to just send it down to plain text and then do some LDAP. I mean, there's going to be many ways of sending down your user and password. You don't want to have to write a client and realize that it's different for one CloudStack instance versus CloudStack instance 2. Right? So with the API key, it's always going to be the same for every single CloudStack instances out there today. So you don't have to worry about someone one CloudStack instance making sure their password is generated one way versus another path. So if you ever want to write a client or anything on top of the API, unless it's your own portal or UI, I would highly recommend that you just stick with the API key. So what this slide is going to kind of go through, I'm going to go step by step on how you can generate the signature. And the reason why we need the signature today is because we need to figure out if the person that is sending the API request is who he says he is. So, in fact, in the lightning talks, you saw that for every user in CloudStack, you get an API key and you get a secret key. The API key defines who you are. Okay, that tells CloudStack that's always sent on every request, and that effectively tells me who you are claiming to be. So, for instance, like your username, basically. That API really defines like your account. The secret key is something that you never pass in the URL. That is something that CloudStack has generated once and is given to you, and that is never shared ever again. And every time we pass any API command. But that secret key is what you're going to use to create the final signature that you're going to send down on every API request you send to CloudStack. What this step-by-step thing does is it generates a signature, and what CloudStack will do is do exactly the same way and as long as the signature matches at the very end, then you have proven to me who you claim to be, and since we have a shared secret key that only class tag knows and only you know, that as a user, then presumably you are who you say you are. And this is very exactly what Amazon does today. So if I take this example, it's kind of small here. So I've broken this down into 5 segments of a API request. So the very first segment, which talks about the local host 8080/clients.http. Okay, that's really just the host name and path. It's going to change on whatever class type instance that you happen to, whoever is hosting the class type instance. And that's really never going to change. The second thing is, the second line tells me what command you're trying to execute. And that the syntax of that is command equals to whatever API command is out there. The third line is the various parameters you can set per command. So each command has different lists of required and optional parameters you can set. And so the third line just shows you 7. The fourth line is the API key. And the fifth line is the signature that we're going to generate. So lines 1, 2, 3, 4, you should be able to create that yourself without any type of programmatic logic. You should be able to just figure out how you want to construct this UI. So how you generate the signature is what I'm going to describe now. So what I want to first define is what is the command string. The command string for me, for this purpose of this exercise, is the command name plus all the parameters plus the API key. Once I take that, so it's really lines 2 to 3. Once I have all that URL, what I want to do is URL encode each of the field name parameters. So API key equals blah, name equals blah. You want to URL encode the blah section. The reason why you want to do that is because you want to make sure that you can pass a safe HTTP request down to the cloud stack server. Step 2, after you URL encode each of the parameters, you want to lowercase that whole command string because I want to make it the final string on the cloud stack side. We just want to make it consistent, so lowercase everything except for that. Then what we do is for each of the field that you paired, you want to sort that command string. So if I took the original command string and I sorted it and URL encode, it would actually look like API key equals something and command blah 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 all the way down. And so that's the string that I'm going to eventually take to create the signature with. That final string right here is I'm going to run the HTTP/1 algorithm and encode it with the secret key that I have. And it tells you you have to base 64 encode it because the result of that is a byte array, which you need to base 64 encode that so that it's passable to that. And if I did all this correctly, the final string should look something like this. And so if I wanted to send an API command down, I would take steps 1 through lines 1 through 4, construct my URL, and then append the signature right to the end and send it to the cloud stack server. When you do that, the cloud stack server will do exactly the same. Now the reason why it's going to do that is because it's going to take the API key and look up your secret key. And now the cloud stack server would have your secret key. It can perform exactly the rest of the algorithm as you would have done. And this final signature, if it matches, then the command will be executed. And so this is what you would do on every single API request that you want to execute in cloud stack. Before I go beyond that, I know this is usually the complicated one. Does anyone have any questions specific to how we can generate the API signature? Everyone understands? Oh, it's English, right? It's good. I think that's, you're right. I believe we do support there is a timeout period or a nonce that you can actually add, expiration time you can actually add down to the API. This specific example does not show that, but I believe you're right. I think in Cloud Stack 3, you can add some type of expiration time to it, or at least some time limits. I believe it is a global setting. Yeah, I think you're correct. There is a way for you to do that now. Yeah, so we added a time factor so that you can replay the URL over and over. Anyone else? Wow, this is usually the most complicated. So the next thing I want to talk about is the difference between a synchronous and an asynchronous API. So the synchronous API is when you make an API command to account stack, it will immediately return with the JSON response of the command that you had executed. And most of the list XXX commands that we have today are synchronous commands. So if I do a list of virtual machines, it will immediately return all the virtual machines or whatever you request. We introduced the concept of asynchronous commands in Cloud Stack because there are commands that will take a significant amount of time. For example, the creation of virtual machine, the creation of disk storage, adding a forwarding rule, or load balancer rule, or what else? Or creating a snapshot. It's very long. And so typically, if you make an API request to create this object, if you just kept waiting for the response, in all likelihood, a firewall will probably cut the connection and you lose it. And so we introduced the concept of asynchronous APIs into Cloud Stack since 2.2, or not since 2.2, but since Cloud Stack was created. But one thing I want to mention, starting with the 3.0 UI, or 3.0 API, so if you, the standard CRUD nomenclature of create, read, update, and delete, starting with 3.0, create, update, delete, all asynchronous. And only the read API, which is the list commands, are synchronous. So going forward with 3.0, any API, if you want to create your own API, please follow this and ensure that any of the create, any of the updates, any of the deletes are going to be an asynchronous API. The reason why we chose to do this was because in the 2.2 world, the developers got to decide what is synchronous and what is asynchronous. And the problem with that is if you had created a synchronous API and in the future you decided, oh, it's going to be asynchronous, you can introduce it, but the problem right now is everyone else has integrated assuming synchronous, which is great. And so we want to standardize this. So in the future, if you decide to create your own API, please follow this the way we have standardized. So quickly about what the asynchronous command does. So instead of getting a JSON response or XML response of the command you executed, you will get a job ID when you execute any asynchronous command. And what that does is, when you execute an asynchronous command, it will be put into a job queue inside the Cloud Stack management server, and then there is a pool of threads that will pick up these jobs and execute them in the background. So with that job ID, and we also return so for example, if you actually executed a create time command, we will also give you the object ID as well as part of the return. So you get a job ID and you get an object ID. And for example, object ID would be if, for example, you executed deploy virtual machine, it will immediately give you the virtual machine ID back along with the job ID. So what can you do with the job ID? Well, now you have a different command out there that you can call query paste job results command periodically and pull for that job ID. And there's 3 states that can come back from that. You get 0 as part of the job stack. 0 means it's still going on. You can get 1 back. That means the job has successfully completed, and it will return you the JSON or XML response to the job itself. And then, of course, if you get 2 back, it means it failed, and it will typically give you a result or reason why that asynchronous command has failed. I believe in 3.0, you can continue to pull for the response up to a certain time limit, and I believe that time limit is configured. Let's see. Yep. And I think the part one so quickly on the formats, we do support two types of formats on return. One is XML, and one is JSON. I don't know what's more popular. I think JSON is a bit more popular today than XML. So, but any of these formats is supported by CloudStack. So I think by default we do send respond XML, but if you append response equals JSON, you'll get a JSON response back. And just for an example of this, if I executed a list IP address command, this is kind of an XML version of that. And the bottom is the JSON, very similar request method. So it really depends on your client how you want to parse it. And then what I was going to quickly show you on the browser is where you can find these commands. So I've within this link, and I can probably give you this link later, but what I've had here is all the API commands that are supported by CloudStack today in 3.0. If you look at whatever has an A parentheses, that means this is an asynchronous command. And if I click onto any of these parameters, it will tell you what are the required parameters that must be set if you execute the command, and all the optional parameters that you can now set. And hopefully, it's not going to go well. If you do decide to create your own API, please refer to one of the existing API commands that have been written, because we do use a lot of Java mechanism of automatically generating the parameters and whether it's required and a description of what it does. So if you follow the convention of creating an API command within CloudStack, we have a tool that will generate an XML document for that. And from the XML document, you can either create this HTML page that we have today, or create the CLI tool you saw earlier that we have in CloudStack, and you can see all the parameters. So we use the XML for that purpose right now. So it can be automatically generated. Okay, so this is, I should mention one last thing. Within the API, this actually is user API. So in fact, it's actually only a subset of the APIs that we have today. We also have a section for admin, and it's probably twice as long as the number of APIs supported. So the user API is really what the CloudStack user can be taught today. And I think for most of you guys that want our partners or vendors or anything on the right on top of CloudStack, you would use this API. Because generally the admin API is something you would never call against. In terms of the CloudStack releases, we tend to ensure that the user API is compatible across each version. The admin API, not so much. So I'll be honest there, the admin API, we've been not as diligent in making sure it's compatible. But we pretty much assume nobody's going to write against the admin API. Most people will already have used RUI to create their zones or their set up their physical infrastructure. Pagination. The reason why we have pagination, and this is available for every single list-based API call within CloudStack, is because we want to limit the result set that's returned by the API. Most browsers cannot take a JSON object that is, order of megabytes huge. At least not today. It'll probably slow down or freeze. So we give you the opportunity to pass in page equals some number and the size of that page. So now, for every list command that you execute, if let's say you knew it was going to be very, very big, you can say, I want to shrink the result set to just return me 500 per result set, and you can keep incrementing more. And I do believe today in all the list commands, we will also return you the total number of objects in that command, even if you said just give me page 1, page size 100, and it's 1,000, it should return you there's in fact 1,000, so you know how many more to work. Okay. Quickly today, before I finish the API addressing, so the CloudStack UI team is working on what we call the UI plugin framework for the future. This should be, they're going to slowly commit a lot of this to the CloudStack project, so you should see it sometime this year, and it will be an evolving process. The reason why we're doing this is really to solve a couple of things. As I went through the slides today, you saw that in order to customize CloudStack, you have to modify CloudStack UI generally. Other than CSS, if you have to modify JavaScript, if you have to modify HTML, the moment you do a CloudStack upgrade, you're going to have to deal with emergency. So we realized that that's not a very efficient way for people to contribute or to modify the UI. If every version they have to constantly merge with the previous version. And if you were a vendor or partner that added value-added UI on top of CloudStack, it's even worse for you because you're going to have to certify your UI in every single CloudStack release that's out there. So we realized that's one of the big problems. The second problem is, as I said before, if you really wanted to modify the UI, there's no real, other than the kind of sample I gave you, which I'm sure all of you guys already forgot, you would have to use Firefox or some type of development tool to figure out what you can modify in order to change the UI. And we realized that that is also a pain in the butt to do. And then, I mentioned versioning becomes very difficult. So some of the future stuff that we want to do is, number one, a lot of the kind of the UI special features like panels or breadcrumbs or pagination, any of that stuff. If you want to write something on the CloudStack UI, you don't want to worry about that. And so we want to widgetize all of that, all those components that's in the UI. So in the future, if you, for example, wanted to use the slide panel, it'd be easier to just declare, use a particular package and say, I want a widget that does this. So that's one thing we want to do. The other thing what we want to do is create a kind of a configuration file or a declaration file. So that, for example, let's take the navigation bar example where I told you you have to modify JavaScript, CSS, HTML, like 3 different places within CloudStack. Today, what we want to do is if we come up with a JavaScript configuration file here, all you have to do is just specify the configuration file. CloudStack will read that and will automatically draw a left navigation window, whatever. And so with this process, all you have to worry about is that declaration file for every version, and so hopefully that thing does not change significantly. And so and then other things that we think that you can change other than the left navigation tab is, for example, adding new actions within CloudStack. For example, if I was someone that wanted to add encryption in volumes, well, you can either redirect the user to a website, or even better, you can have an action within CloudStack UI that says encrypt my disk volume. And it's just much more seamless to the user to go through one UI than to go through CloudStack UI and have to click through various portals in order to do what I want to do. And the last thing that I actually haven't mentioned here is we are also trying to implement what we call, very similar to Amazon Marketplace. So we want to have vendors be able to submit their application to CloudStack, whether it's a CloudStack project or not, it's TBD, we haven't decided yet. But we want our partners or vendors to submit UI code, plugin code, etc. into a location where the CloudStack UI can read from that and display it to both the administrator, for the administrator to choose what application they want to put into CloudStack, and number 2, whether the user also wants to select that application to use as well. So we plan on doing that kind of a storefront marketplace for both admin and for the users in the future as well. So that's kind of the future thing we're thinking about doing. The patching. So before I even get to there, I'm going to quickly show you tips on Firefox. Okay, so just quickly through this, I'm going to show you this log. Okay, so if you use a tool very similar to Firefox, you're going to see that every single API command is actually being called here. And as I said before, the Cloud Stack UI almost makes 95% of the API call that we have today. So it gives you a really good head start what you want to do, kind of the parameters you want to choose. So for example, here's the list capabilities command. It tells you the command, some of the parameters that we have sent in, zones, et cetera, et cetera. And if I open one of these things, it'll actually give you the response as well. So something like a Firefox, Firebug, is a very useful tool that you can use. So if you don't know which API call to use, you can just click around the UI, open up Firebug, and it'll tell you exactly which API and how the response looks like when you get the result. So I highly recommend you use something like this in any of your development and how you want to make API calls. That's something I have used myself frequently, both for debugging and both